Okay, this is the introduction to paired data. So what is paired data? Data are paired when the observations are collected in pairs. Well, that's kind of a duh. In other words, there's two samples that have a relationship. So they're two, it's related together. Now, there's going to be a distinct difference between it and from what is known as a two-sample test. You're like, well, wait a second. A two-sample test is different than a paired, and yet you're saying that a paired has two samples. Yeah, a pair does have two samples, but these are two independent groups. A two-sample test is two independent groups. And we will study those after spring break. Here we have, in a paired sample, we have a natural relationship. So we have a natural relationship. Paired is a natural relationship. And typically with a paired, something is tested twice. So how do I recognize whether we have a natural relationship, in other words, a paired test, or a two-sample test? How do I know if it's a natural relationship or two independent groups? Well, for right now, we're just going to focus on how do we recognize a paired test, because we'll worry about the other after spring break. So in a paired test, a subject is measured before and after. So if we have a before and after situation, then it's going to be a paired test. And basically, each individual is measured before and after, and the individuals before and after are computed. So it'd look like for individual one, we'd go the before measurement minus the after measurement. For individual two, we would do a before measurement minus after measurement, and so on and so forth till we take care of all the individuals. Another type of paired test is when we specifically test something twice. And if we think about the mosquito situation we worked with at the beginning of the year, we sprayed one mosquito repellent on one arm and another arm on the other arm. So this really wasn't a before and after. They were both you were tested twice. You put one arm into the one spray and the other arm into the other bin of mosquitoes, and we'd count how many bites you got. And because we were basically testing you twice, although at the same time you receive two test streams, this is also a paired test. Now, the ones that are a little more difficult to distinguish or a little special cases are when we have naturally occurring couples or pairs. When I see couples, that immediately makes you think of a dating couple or a husband and wife couple, and those can be pairs, and we'll talk about them here in just a second. First off, we really like testing twins in statistics. Why? They're similar. They often grew up in the same household. They were subject to the same DNA, etc. And typically in a pair, no individual is tested twice. One individual would receive one treatment and the other would receive the other treatment. And then we take pair one, and we'd have the one pair with the one person minus the other person. So you'd subtract the differences between the sibling. All right. Mosquito bite of sibling A had this many bites, and sibling B had this many bites, and we'd subtract the difference. We might also do something with spouses, where we can compare a husband to his wife. Now, be very careful about this. Husband to his wife is a paired test because there's a natural couple there. But if I just compare married women to married men, that's not a couple situation. It has to be the husband matched to his wife. Siblings. A sibling, if they're compared to his or her sibling, can also be a paired test. So that's another special case of a paired. So basically, a brother to his other brother, or a sister to her sister, or even a brother to a sister, as long as we're matching one for one. All right. Now, notice for a matched pair design, we are looking at the difference between each pair. We're looking for a difference between each pair. So we're subtracting, we are subtracting not once, we are subtracting for every set of pairs. So if we have 100 pairs, we'd be subtracting 100 times. Okay, and that's another distinction between it and a two-sample test. Another thing to know is if we're running a matched paired test, the list of data, it says a list of two samples, but let's make this, we have two lists of data, and the two data lists must be exactly the same length. Why? If you were measured twice, then you'd have a data for one and a data for the other, where you got one treatment with one treatment with the other, so you were measured twice. As I mentioned earlier, we have worked with paired data before. You might recall when we created a matched pair design for experiments for waterproof boots and for mosquito repellent. Remember, we put one boot on one foot and then a boot with a different treatment on the other foot? Or we had one mosquito spray A on one arm and mosquito spray B on another arm? So my question to you is, why did we do that? And I know it's been a long time, so to refresh your memories, I will tell you, we did that, this is really important, to control for the differences between each individual. For instance, some people are very, very susceptible to mosquito bites. So because they get lots and lots of mosquito bites and other people don't get that many, it might be nice to know, well, how much did that spray help? We put one spray on one arm and one spray on the other arm, and we go, you know what? It helped the one that got a lot of mosquito bites a lot, whereas the other person only got 2 or 3 mosquito bites with no mosquito spray. Now they're getting one bite. That's not a huge difference. But on the one who's very susceptible, they were getting 90 bites and now they're down to 3 or 4. That's a huge difference. So we want to control for those differences between individuals. Also, there's certain people, like if we talk about sunscreen, there's certain people very susceptible to sunburn and others that are less. And a paired test will allow for us to control for those differences. We love running paired tests. Unfortunately, it's very difficult to do so. And sometimes it makes no sense. If we want to know, here's an example of one that it doesn't make sense. Perhaps someone breaks their leg and we want to try out a new treatment protocol to see if it works faster. Well, once we've done that and they've gotten healed, we can't test them twice without going back and breaking their leg. So that doesn't make sense. So we'd have to have a two sample, or we had one group get one group of people with broken legs get one treatment, and another group of broken legs getting the other treatment. So paired test, we like to do it in order to control for differences, but it's not always possible. Once again, please note, we calculate the difference for each pair. We're subtracting each individually, all right? And once we've done so, once we've subtracted each individual, we create a single sample of differences. It's that single sample differences that we use in our calculations. So basically, what this really just means is we took 2 columns of data and turned those 2 columns into a single data. And basically, it was the data of the differences because we subtracted. We just took 2 numbers for each people and we subtracted. So in other words, if I had a sample of 50 people that were tested twice on the mosquito bites and we counted the number of bites for each person, it's like, okay, they got that many on arm A, this many bites on their left arm, this many on the right arm, subtract the differences, and then we look at all those differences and there'd be 50 differences, okay? It's also important to note, we do not take the mean of each sample and then compare the means, all right? We do not take the mean of each sample and compare the means. If we take the mean of each sample and compare the means, that's a 2-sample test, all right? This is a 2-sample test. In a paired test, we're subtracting for each individual, and we're going to take the mean of all those differences. All right. So in the next video, we will do scenario 1 and go through that.